Hi guys, today we're going to be working on student handout 5. We're going to be moving into multiplying and dividing integers. First we're going to start by using models or pictures, and then we'll move into the algorithm just like we've done with all of our previous lessons. So let's go ahead and get started. Multiplying and dividing integers with models. This says Mrs. Daphne orders her puppy treats from an online store. Listed below are her options to purchase. Rewrite each option as a math expression using multiplication, then sketch a picture. So she's got a couple different ways she can buy treats for her dog, and we're going to just write out an expression to show what the multiplication sentence would look like. So one way she can buy treats for her dog is to buy 4 boxes with 3 treats each. So to represent this as a multiplication expression, I would say 4 times 3. To draw a picture of it, I could draw 4 boxes to represent each box of dog treats, and then I can put 3 treats in each one. I'll just use tally marks. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is one way to sketch it. The other option that Mrs. Daphne has is that she can order 2 boxes of 6 treats each. So this would be represented with 2 times 6. So now I'm going to draw 2 boxes, and in each box there's going to be 6 treats. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now both of them will give her the same amount of dog treats, 12, but these are just different ways that we can use to represent them. So let's move on to some other examples. Since multiplication is repeated addition, models can be used to represent integers as well. Model and solve the following multiplication problems. So we are going to use the same kind of counters, positives and negatives, to represent multiplication just like we did addition and subtraction. When we represent multiplication, it's going to be similar to back when you were in 3rd and 4th grade, where you used arrays. You used rows and columns in order to represent multiplication. The only difference is, instead of drawing little circles, we're going to represent positive numbers with plus signs and negative numbers with minus signs. So whenever I look here, I see 2 times 4. That means I'm going to make 2 rows, and each row will have 4 in it. Now, since they're both positive, then I'm going to put 2 rows of 4 each plus signs. So here's 1, 2, 3, 4. And then I have 1, 2, 3, 4. Now, since there's an equal sign here, that means they want me to solve this equation. So I know that 2 times 4 equals 8, a positive 8. And if I counted those, I would get positive 8. Now let's look here at the second question, because this is going to change a little bit. Anytime we are multiplying or dividing, the rules are a little bit different. When I'm multiplying numbers and they have the same sign, either both of them are positive or both of them are negative, or I'm dividing and they're both numbers are positive or both numbers are negative, my answer will always be positive. Those negatives cancel each other out. But when I'm multiplying or dividing and my signs are different, one's a positive and one's a negative, like in this example, then my answer will always be negative. So 2 times negative 4 means make 2 rows with 4 negatives in it. 1, 2, 3, 4. 1, 2, 3, 4. So I know that 2 times 4 is 8, but since these are negatives and our signs are different, my answer in this case will be negative 8. Now let's look at one more example for number 3. I see 2 times negative 5 equals something. So this means I make 2 rows with negative 5 in each. So I have 1, 2, 3, 4, 5 negatives. 1, 2, 3, 4, 5. So I know that 2 times 5 is 10, and because I have the 1 negative sign, it's going to make this answer, or product, a negative 10. So now let's look at the questions down below. This says if 2 times 4 equals 8 and 2 times negative 4 equals negative 8, then what do you think -2 times -4 equals? Well, we already said that these negatives cancel each other out. So what we know is that if our signs are the same, both positive or negative, our answer or our product will be positive. So those negatives cancel each other out, and we would get a positive 8 by multiplying -2 times -4. So let's talk a little bit about the patterns that we're noticing above. So when we're multiplying integers with the same signs, we multiply integers with the same signs. So that could mean positive and positive, or negative and negative. The product is positive. When our signs are different, meaning one positive and one negative, or a negative and a positive, our signs are different, the product will be negative. And B says, since division is splitting a set into groups, predict how this pattern up above will apply to division. So the same pattern will apply because they're opposite of each other. Multiplication is the opposite of division. Multiplying is repeated addition, and division is repeated subtraction. They're inverse operations. So the rules will apply in the same way. As multiplication. So if our signs are the same, either positive and positive or negative and negative, then our quotient or our answer, that will be a positive. But if our signs are different, a negative and a positive, or a positive and a negative, then our answer will be negative. So down here, we're going to model and we're going to solve the division problems below. So I see 9 divided by 3. I see my signs are the same, so I know that my quotient will be a positive. I know 9 divided by 3 is 3. And the way I like to explain this to my students back when I taught younger grade levels was whenever we're doing a division problem, I like to consider it sort of the equivalent of if I had some friends over to my house and I made chocolate chip cookies. And everybody would get upset if I gave an uneven amount of cookies to everybody. So whenever we're dividing, we're looking to do equal groups because everybody wants to have an equal amount. So in order to model this, the second number, our divisor, tells us how many groups we're going to make. And I always just have made them circles. It's just easiest for me to draw that. So I'm going to draw 3 circles because that's how many groups we're going to have. And now I need to take and distribute this 9 evenly to each group. So I'm going to say 1 cookie, 2 cookies, 3 cookies. I'm going to give everybody 1 cookie before I start over again. 4, 5, 6, 7, 8, 9. So now I look at one group to see how many cookies are in there, and there's 3. Now I should note that these should be plus signs because these are all positive numbers. So instead of just putting tallies, we're going to put positives or negatives to help us know our correct answer. So let's look at number 6, because here's where we're going to use negatives. This says negative 9 divided by 3. Well, I see my signs are different, so I know that my answer will be negative. So negative 9 divided by 3 equals negative 3. But let's just check our work with a model. So again, this 3 tells me how many groups I'm going to have. So I'm going to draw 3 circles. And now I'm going to distribute negatives, 9 of them, among these groups evenly. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I count in my group, I do have negative 3. You go ahead and do number 7 on your own, pause the video, and then come back and check your work. All right, let's look at number 7 together. I have negative 6 divided by 2. I see my signs are different, so I know that my answer is going to be a negative. I know that 6 divided by 2 is 3, so this will be negative 3. I'm just going to confirm by showing a model. This again tells me how many groups I'm going to have. In this case, it'll be 2. And I'm going to evenly distribute negative 6 to both. So I have 1, 2, 3, 4, 5, and 6. I count how many I have in one group, and I can confirm that it is negative 3. So let's turn it over to the back. And now we're going to look at how to model the same concept using a number line for multiplication. So this says, now try modeling the following problems with a number line. Always begin your model at 0. So when we are modeling this, we always start at 0, and we're going to do basically skip counting. I call them hills, but we're going to be modeling using skip counting to show our answer. So for number 8, I see 3 times 3. So that means I'm going to start at 0. I'm going to jump in groups of 3, and I'm going to do this 3 times. So I'm going to skip count by 3. So I do 3, there's 1 hill, 3 again, which is 6, and 3 again, which is 9. So now I have 3 hills, and each one of them skip counted by 3. So where my final one rests, that's the answer to my math problem. And I know that 3 times 3 equals 9. Now the reason I went right is because both of these are positive numbers. You're going to see an example in just a second of what happens when we have a negative number. So number 9 says 5 times negative 1. So again, that means I'm going to start at 0. This is telling me that I'm going to go to the left into the negatives 1 time, and I'm going to do this in a group of 5. Sorry, one group, negative 1, 5 times. So I'm going to have 5 little hills in the negative to the left. So here we go. I'm going to go 1, 2, 3, 4, 5. So I have 5 little hills, each group negative 1. So this gives me an answer of negative 5. Let's do number 10 together, and then I'll have you do number 11 on your own. So number 10 says 2 times negative 3. So I know that I'm going to start at 0. Because I have a negative, I know I'm going to be drawing my hills to the left. Each group is going to be negative 3, and I'm going to have 2 groups. So I'm going to be skip counting by negative 3. So I'm going to go negative 3. There's 1 hill. Negative 3 more is negative 6. Here's my 2 hills. So 2 times negative 3 equals a negative 6. Now go ahead and you do number 11 and then come back and check your work. So number 11 tells us 2 times 5. That means I'm going to be skip counting by 5, and I'm going to be doing that 2 times. Now I don't have any negatives, so this is all going to be to the right of 0. So if I skip count by 5, I go from 0 to 5, and then I go 5 more, and I get 10. So 2 times 5 equals 10. So now let's go down here to the bottom. We're going to use our knowledge of number lines and models to draw out and show our pictures to solve multiplication and division integer problems. So we're going to do a couple together, and then you're going to go and do the rest of them on your own, and then come back and check your work. So number 12 is 6 times negative 5. Now I like to use the counters. I just think they're a little bit easier to draw, but whichever one works better for you, whether it's number lines or the counters, that's the one you should use. So I have 6 times negative 5. I see my signs are different, so I know that my answer will be negative. So I'm going to have 6 rows with negative 5 in each. So I'm going to draw 1, 2, 3, 4, 5, and I'm going to go down 6 times and across 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my last row, 1, 2, 3, 4, 5. So I know that 6 times negative 5 is going to be a negative 30. If I counted all these up, there'd be 30 negatives. Let's go ahead and do number 18. So number 18, I have 2 negatives. I know that whenever I have negatives, the negatives cancel each other out. So these really are going to be positives. So I'm going to have 11 positives across, and I'm going to have 4 rows down. So I'm going to be drawing a lot of plus signs here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm going to repeat that for 4 full rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And my last row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, those negatives cancel each other out. Double negatives actually give me a positive answer. So I would get 44. So I want you to go ahead and do the rest of these and then come back and check your work. I'll go through those quickly. All right, let's go through and see how you did on your work. So 4 times negative 5, I see my signs are different, so I know my answer is going to be a negative. So I'm going to have 4 rows with negative 5 in each. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So I have negative 20. I have 20 negatives if I counted all those. Number 14 says 6 times 5. So I'm going to put 6 rows with 5 pluses in each. I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And my last one, 1, 2, 3, 4, 5. So 6 times 5 is a positive 30. Now let's look at number 15, which is a division problem. So when I'm doing division, I need to look and see how many groups I'm making, which in this case is 8, and what am I sharing among the 8? And I'm sharing 16 negatives. So I'm going to draw 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. Now I know what I'm sharing amongst them is negative 16. So I'm going to distribute each one, and then I'll start over to evenly distribute my negative 16. So I have 1, 2, 3, 4, 5, 6, 7, 8. Now I start over. 9, 10, 11, 12, 13, 14, 15, 16. And to solve this, I look at one group and I see what is there. So I have negative 2 as my solution. Let's look at number 16. I have 28 divided by negative 7. So I know that I'm going to make 7 groups. 2, 3, 4, 5, 6, 7. And now I'm going to distribute 28 and I'm going to make those negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Now I look at one group because I've evenly distributed them and I see that each group got negative 4. Number 17 says 6 times 9. So I know these are both positives. I'm going to have 6 rows with 9 pluses in each. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my last row, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know that 9 times 6 is 54. So if I counted all those up, I'd have 54 plus signs. Both of them are positive, so therefore my answer is positive. And let's look at number 19. I have 80 divided by negative 10. So I know I'm going to have 10 groups of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My signs are different, but I'm going to be distributing 80 negatives to all the groups. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. So now I look in each group and I see that I know that 80 divided by 10 is 8. So each group has negative 8. Now let's look at the last two word problems before you get started on your homework. Number 20 says Ashley and her sister decide to split the cost of dinner, which is $14. How much will each sister pay? Model the problem below. So they don't give us all the exact numbers or operations, but we have to read between the lines and figure that out. So this says Ashley and her sister. Well, if I'm counting that, I see that that's 2 people. And what they've done is they've eaten dinner and they're going to split the cost of dinner, which is $14. If I'm going to split the bill with somebody, that's a division problem. So this is the same as saying that they spent $14 and they're dividing that cost among 2 people and it's going to equal some amount of money. So I'm going to go ahead and I'm going to draw out my picture because it tells me to model my problem. So I know I'm going to have 2 groups and I'm going to split $14 up amongst both. So they're both positive. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And when I look, I see that each group has 7. So that means each person will pay $7 worth of the bill. Now let's look at our last question. Number 21 says Alejandro sketched the model below. Which expression did Alejandro model? So we know already that one of them has to be negative. So that means our answer for this problem has to be a negative answer. We know that if both have the same sign, that it can't be that. So automatically looking at B, I know it can't be that because both of them have the same sign, which would mean that our answer would be a positive and our answer is going to be negative. Now the second thing I'm looking at is that I see 2 rows and each row has 4 in it. So 2 times 4 is 8. So I'm looking for something that has a solution when I solve it of 8. So when I look here, I see it says 4 times negative 4. Well, I know that 4 times 4 is 16. So it's definitely not going to be that. We're not adding it. So I know that it can't be A. C says 2 times negative 4 equals something. So this is 2 rows, and each row does have -4, and I know that 2 times -4 would be -8. So this is a good possibility, but I'm going to also check letter D. So D says 4 divided by -2. Now this isn't how we've been practicing modeling division, and if we were going to take -4 and divide it by 2, it would give us -2, and this does not give us -2. So correct answer for this question would be the letter C. So go ahead and finish writing that down, and we will tape this in, bring it into class, and we will get it taped into your notebook where it belongs. And now you're going to be doing homework number 5 tonight for your assignment. So they, just so you know, 1 and 2 are division problems. They model their circles a little bit differently than I do. So you're going to use the same stuff that we learned for 1 through 5, and then 6 through 10, they want you to model and solve those problems. And the last 2 are word problems, so make sure you read through those and underline the important information to figure out what you're modeling. Good job today.